So let's start. Now, yesterday we did complete entire carbohydrates. One reaction which was neither in NCRT and nor in our brochure clearly mentioned, but is one of the very important reactions. So I just reviewed it. Okay, let us add this also. I'm adding this. Osazone formation. Now, osazone formation, aldose sugars react with pH NH2 and NH2OH to form phenylhydrazone and oxime respectively. Okay. With excess of pH NH2, orange, yellow, crystalline, and this particular is not just aldose. This will be given by ketose also. Okay, it is not about aldose, ketose, both type, and oxime respectively. With excess of pH NH2, orange, yellow crystalline solids are formed, and these are called osazones. So the basic thing that you remember is whatever is down here, like whatever is down here with the top two I consider, and then the rest all I mean ki only first two involve some change and rest remains same. So there is a formation of yellow crystalline solids. These are called osazones. Now, what are these osazones? Osazone formation is not limited to carbohydrate, but is typical of all alpha hydroxyaldehyde, alpha hydroxyketones. In general, like benzoin condensation can also give osazone formation. So it is a property of alpha hydroxy carbonyls, we can say. Okay. And what happens is this alpha hydroxy, these two centers, ultimately both are converted to oxime. Both are converted to phenylhydrazone because we are using phenylhydrazine. So two sites are converted to phenylhydrazone sites, and these two sites are compulsorily position number alpha OH and C double bond. Rest, everything will remain unchanged. Though the mechanism as such in detail is not there, but I'm sharing it with you. I'll try to be limiting, not too vast, but yes, in total reaction, only C1 and C2 are reacted. Rest part of the molecule remains unchanged. There is no change in rest part of the molecule. So first what happens, for example, if I take glucose, I take fructose, I take mannose, whatever the rest pooch is same, the top two has some variations. So I took H2O, right? So simple this ammonia and derivative reaction with carbonyl, that reaction we are using, and I have a phenylhydrazone formed here. But as the position alpha, one is having OH. So this is something different. Check this one. Okay, what is happening? See some sort of H bonding you will feel. OH, this NH is having a lone pair H bonding. 6-member chelation. Now this chelation is breaking. How is it breaking? If you will see that, you will understand that this second carbon, which was hydroxyl, is now becoming ketone. And the one which was phenylhydrazone part, that has become imine and aniline is free. Now, as I have told you in aldehyde ketone chapter, that imine will behave very much similar to ketone. Same way this reaction will take place. And we have again 2 moles of phenylhydrazine reacting with our molecule, both side phenylhydrazone form. Yes, the reaction could have been proceed for further hydroxy, alpha hydroxy more. But what happens that once these two centers reacted and we have this osazone formed, it is a precipitate. Okay, yellow, orange, crystalline precipitate. So they go out of the medium, and thus there is no effect, no impact of any further phenylhydrazine on rest of the carbonyl centers. Right. Now, what is important that such monosaccharides which differ at C1 and C2 only, And when I say differ, I'll write in bracket, differ in functional group or in configuration of chiral center. Configuration of chiral center. Any difference? Anna? Such monosaccharide which differ at C1, C2 only will give same osazone, identical osazone, because the entire change that comes is only at position number 1 and 2. For example, if I say D-glucose, D-glucose I have tried to make you learn yesterday also. Again, I drew the fissure vertically CH2O. CHO should be there here. चलो इसे CHO करते हैं. CHO. Now right, left, right, right, like this. Okay. So this is D-glucose. Now the difference is, now the molecule is a aldohexose. If I draw D-fructose, it is first two setting change. Rest if I could use, I'll say it is just a repeat. Okay. It is a repeat. Like this I can use. I'll remove the line I drew and I'll continue like this. Right. Similarly, if I had one more possibility, what could it be? This change, left, left, right, right. So this was D-fructose. I think all of you must be remembering this. I yesterday mentioned it is D-mannose. Okay. Now, if you see that what part is same, if I compare this part of the molecule, just check, it is same. It is identical in all the three cases. This part is identical. Left, right, right, left, right, right, left, right, right. Whatever the difference is here only, right? The entire difference thing, if we are told, then we'll say the entire difference is in first two carbons. Whether the difference is in the configuration or the difference is in the functional group. Is that appropriately marked? And a difference only at C1, C2. From C3 to C6, they are identical. So these three will give identical osazone. Okay, they will give identical osazone as they have exactly same behavior. Is that correct? समझ आई बात? ठीक, they have same osazone. Now, similarly, one more type of question can be framed by the logic. First, this is a very common question. How many of the following will give the same osazone? So you will check this. Difference should be C1, C2. Second question is to have osazone formation from 1 mole of monosaccharide. How many phenylhydrazines are required? 3 moles of phenylhydrazine required per mole of monosaccharide. That is also fixed. Okay, that is your type 2 question. Type 3 question, let me tell you. Now, once the product is formed, okay, once that product osazone is formed, now that osazone, okay, once that product osazone is formed, those osazones will be identical. Okay. If they are identical, they will have same melting point, boiling point, and all those properties. So you may be asked that which of the following will give osazone which have identical melting point, identical boiling point, indirectly, same osazone ki jagah. Question can be reframed in terms of their properties also. Okay. So this is also one of the important reaction that you should know, and it is not just aldose. Here I am exemplifying to start with aldose, but on page 2 I am very clearly mentioning osazone formation is not limited to carbohydrates alone. And it is a property of alpha hydroxyketone, alpha hydroxyaldehyde. All of them will give this particular reaction. Okay. Now let us start proteins. Now, protein word is derived from Greek, yes, word proteos, meaning, I think I did a spelling error, meaning of primary importance. Okay, proteins are building blocks of bodies, all this part you know. Amino acid could, and they are polymers of amino acid. Amino acid could be any compound with amino and acid functional groups. But all naturally available amino acids are only alpha amino acids, and that too only in L configurations, though they may have other functional groups also. All amino acids are chiral in nature, except smallest amino acids are called glycine. It is a chiral, rest all are chiral. Rest all naturally available amino acids are found only in their L configurations. Please remember this in particular, that all naturally available amino acids are found only in their L configuration. Okay. All amino acids are chiral except glycine. And all naturally available amino acids are alpha amino acid, though by definition it could be alpha, beta, gamma, delta, anything. Okay. And there may be presence of other functional groups, that is okay. Now here is the L amino acid. For amino acids, the term capital D and capital L, like yesterday we did that in a conventionally correct fissure of a monosaccharide, if the highest IUPAC numbered chiral center has OH on the right hand side of the fissure, then we'll call it D sugar. If it has on the left, then we'll call it L sugar. Right? This is what we did yesterday. Now here, if we want to use it same, in case of amino acids, we say that the alpha positioned NH2 group, if is on the right hand side, then D amino acid. If on the left hand side, then it is a L amino acid. Okay. And yes, these are all the amino acids. They have trivial names in use. They are also represented as one letter or three letter symbols like glycine, G or GLY, alanine, A or ALA, valine, C isopropyl group. Okay, leucine, isobutyl, isoleucine, secondary butyl. Okay, phenylalanine. We have to remember all these ultimately. Tyrosine is a CH2, PHOH. Then I have tryptophan, which is having this complex substituent. Serine, CH2OH. Threonine is CHOH, CH3. Cysteine, CH2SH is the alkyl part. Cysteine is just a dimer of this. Okay, it is just a dimer of this. Methionine is CH2CH2SME. Proline is the only one having alpha amino as a 2-degree nitrogen or 2-degree amino group. Okay, so this is important because this is the only one where this is a 2-degree amine group. Other all have primary amine group as this alpha center. Here comes asparagine. Okay, before that I want to go to aspartic acid. It is CH2COH. Glutamic acid, CH2CH2COH. If you take amides of these two, aspartic acid amide is asparagine, glutamic acid amide is glutamine. Lysine, 1, 2, 3, 4. CH2, 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 NH2. Arginine, CH2, CH2, CH2. And then this is your guanidine substitute. Very, 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 what should I say, good base. Histidine. It is relatively complex. Okay. Now, I want you to memorize all these with time. What time should I say? I don't know. But yes, you have to memorize these. And better to memorize it as soon as possible. My suggestion to somewhat, agar aapko isse help ho, if this could help you, I have done only one way, repeated writing, but still, like, see, first letters I took, and I took it as G, Gov, Lip. I took this. GAVLIP, Gavlip. Okay. And then I started, G stands for glycine. And then you have to remember what is the R. I took this as a fixed structure and started memorizing R. Okay. So for G, it is H. Alanine. That is what I will suggest. Practice it like this. So it is CH3. Okay. V was valine. Valine is isopropyl. L is leucine. L, overall there are two, leucine and lysine. But lysine is a basic amino acid. Leucine. Leucine has like this. Okay, so 1, 2, 3, like this. It is a isobutyl group. Then comes the isoleucine. And here it is 1, 2, 3, 4. And from this secondary butyl group is leucine. P is phenylalanine. See, alanine we know, na? Phenylalanine is PHCH2. Then it is phenylalanine. So you ultimately have to memorize. This is the basic which should at least, for me, my request is learn all 20. Learn all 20, but still kuch to aana chahiye. Some you need to memorize. So see, I am helping you memorize. Please write in your rough notebooks with me only. So what it is, COH, R, NH2H. Now these R we are memorizing. Gavlip, glycine H, alanine CH3, valine isopropyl, leucine isobutyl, isoleucine secondary butyl. P is phenylalanine. So we are done with 4. Okay. Now once you are done with 4, you may say that, madam, आपको तो याद है इसलिए आपको easy लग रहा है, but याद करना पड़ेगा. Okay, tyrosine and tryptophan we'll learn later. See, serine, CH2OH. Now you should learn as a set of OH group containing amino acids. So 3 there are. OH containing 3. One is serine, one is threonine. Serine is CH2OH, threonine is CHOH, CH3, and the third is phenolic, because they may ask which of the following will give neutral FeCl3 test. So tyrosine will give. That is how it may appear indirectly. So ultimately you have to learn. And yes, there is always a choice that you can be a crybaby, itna yaad kare, utna yaad kare. That is your choice. And for that, I can't say anything. If you want to be that, then you can leave it. If you want to score, you have to do it. So cysteine, CH2SH. Methionine is CH2SME. See, cysteine and methionine, CM sir hai. It is CM sir. CH2SH, CH2SME. So the one which is coming later is having more carbon. And aspartic acid, glutamic acid are also related. CH2COH, aspartic acid. CH2COH is glutamic acid. And similar name, asparagine and glutamine, are their amides. CH2CONH2, CH2CONH2, CH2CH2CONH2 is They are just the amides of aspartic and glutamic. Okay. Basic amino acids. Basic amino acids, we have three basic amino acids. Lysine, which is 4 times CH2NH2. Arginine, 3 times CH2 and guanidine. Histidine is CH2 and this structure, right? So from point of attachment, you have nitrogen and then again nitrogen. Alternate position. And first side immediate nitrogen, other side alternate position, that you can. And this is a full amino acid. It is not the R we are writing here, with a 2 degree NH group. So I have again asked you to keep learning it. याद करो इसे, जितना याद कर सकते हो उतना याद करो इसे. And once you will learn it, it will become very, very easy and scoring topic. Okay? So classification of amino acids based on body requirements. Like some of the amino acids our body can obtain from the food that we eat. Some we have to have some of the amino acids our body can create, can generate, can form. Some we have to have supply through food. Okay. So essential amino acids are those amino acids which our body fail to synthesize. Whatever we give, we don't know how to synthesize them. And thus, they have to be supplemented through diet. You have to eat the right type of diet to have those in your body. Now, how to memorize essential amino acids? Again, I am giving you a shorthand. Private Tim Hall. Okay, Private Tim Hall. Now, Private Tim Hall, again, you will have a problem. Which one is which? Yes, but still now you can remember how many of them are essential amino acids. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are essential amino acids. So P is phenylalanine. V is valine. Okay, there were 2 V. One is valine. Sorry, there were 2 L. One is valine. Here 2 L. T is tryptophan. What was tryptophan? Tryptophan was CH2 and then ring per OH. That was tryptophan. What was valine? This was the valine. Phenylalanine, yes. PHCH2. Whatever, जो याद है उतना करो. ठीक, this was tryptophan. I think tryptophan I did wrong. I am feeling that I just placed this tryptophan thing wrong. Tryptophan is this one, na? That is why I was having that hesitation that something have wait Ekansh. Tryptophan should be corrected. This is not tryptophan. है ना, tryptophan ये नहीं है. देखा, प्रैक्टिस करते करते भी एरर होगी. But I immediately realized na कि there is some error. Like, so that is only when you keep on writing CH2 and then S. CH2 and then wave. CH2 like this. Threonine. So threonine, as I said, was CHOH. Serine was CH3. CH3CHOH. ठीक? Then comes the methionine. Cysteine and methionine, I just told you. CM sir. So it was CH2. See, methionine was the sulfur containing CH2, CH2, SME, CH2, CH2, SME. Keep writing. जितने बार लिखोगे उतना बार काम होगा. Isoleucine. One was leucine, one was isoleucine, secondary butyl. Histidine, leucine. Leucine is this one. Lysine, I said 4 times CH2 and NH2. Arginine was CH2 3 times, right? NHC double bond NH, NH2. and histidine was this one. Okay, so what was histidine? Histidine, in which we had connection with CH2. Then from the point of linkage, one side is nitrogen, one side, one alternate position nitrogen, right? And it doesn't matter practically where I place the double bond like this, because ultimately it is tautomerization possible and it can have the movement, but this is what I am placing. Okay, so this is how I drew all the structures, and this you have to keep practicing. Arginine and histidine are also called semi-synthetic. Arginine and histidine, as they are essential in children but not in adults. In adults, we can synthesize arginine and histidine. Non-essential amino acids are such amino acids which can be synthesized by the body if the required raw material is provided. So, which are non-essential? Rest 10 amino acids are non-essential amino acids. Naturally available amino acids are 20. Yes, Ekansh, now you raise your hand, so I'll allow you to unmute. What were you asking? Yes, tell.
Ma'am, I was just telling about the tryptophan at that time.
Okay, okay. And just I want all of you to today itself, if possible, after class, write 2-3 times all these things. Once you will be done writing, I understand that you will forget by mains and then you will forget by advance, but definitely you will remember some part. Okay, the way I wrote and then I realized, no, it is not. That type of stage, it will come if you will write 2-3 times. Okay, so just do that. So coming to next classification of amino acid. First classification we did was essential, non-essential, and arginine, histidine are semi-essential. And to learn essential amino acid, we use that private Tim Hall. Now we come to on the basis of number of COH and NH2 groups in the amino acid. They are classified either as a neutral amino acid. When in the entire amino acid molecule, number of NH2 and number of COH groups are equal, then it is called neutral amino acid. Okay, acidic amino acid, when the number of COH is greater than number of NH2 groups, then it is called acidic amino acid. Okay, then comes the basic amino acids. When in an amino acid, number of COH group is less and number of NH2 groups is more, then it is called basic amino acid. Now, here again, let us revise the name. Better we go for acidic and basic amino acid name, and rest all will go into the neutral amino acid zone. Acidic amino acid, it means aspartic acid, glutamic acid. Okay. Now again, in your rough notebooks, write the structure of aspartic acid and glutamic acid. Aspartic will have CH2COOH. Let us see. Find. CH2COH is aspartic. Glutamic is CH2CH2COH. Is that clear? I hope this is clear to all of you. So I'll write again here. Aspartic was CH2COOH. Glutamic is CH2CH2COH. Their amide were named as aspargine and glutamine. They are in neutral zone. Glycine, alanine, valine, and leucine we have already done. Again, writing in glycine, it is H. In alanine, it is CH3. In valine, it is isopropyl. In leucine, it was isobutyl. Basic amino acids, repeat. Yes, I know I am repeating it a number of times. Intentional it is. Lysine. In arginine, it was three times CH2, and then comes NH, C double bond NH, NH2 guanidine thing. Highly basic. In histidine, it was CH2, then comes the point of contact, and there was a NH double bond N H single bond like this, right? This was histidine. Some important other observations, like what type of properties there are and how they can be asked. So only two amino acids have sulfur. One is cysteine, one is ethionine. Cysteine, which is a dimer of cysteine, is usually not considered as a separate amino acid. Okay, cysteine was CH2SH and methionine was CH2CH2SME. Right? Let us check again because there is always a scope of कि भूल गए. ठीक, चलो ढूंढो कहाँ है अपना cysteine. Cysteine CH2SH, methionine is CH2CH2SME. Yes, correct. Two amino acids have alcoholic group. Two amino acids have alcoholic group. Serine was CH2OH and threonine was CHOH CH3. ठीक. Phenolic was, we'll go and check all three at once, okay? And phenolic was CH2 and then this type of para position OH. चलो check करके आते हैं. Just 2 pages back की तो जाना है. Serine was CH2OH, threonine was CHOH CH3 and tyrosine was CH2 and then phenolic. ठीक, बढ़िया. Proline is the only amino acid which has a secondary amino group. Yes, I have told you that here we are writing not just like NH was a secondary part. Anna, let me check this structure also. See COH, carbon, and then directly this 5-member ring, NH is there. 5-member ring, NH is there. Amino acids which have aromatic ring attached in them are tyrosine, tryptophan, and histidine. Let us check all of these. Tyrosine, here ring is aromatic. Tryptophan was benzene and then NH like this, right? One CH2 was also there in tryptophan. One CH2 was also there in tryptophan. Let me add that also. So CH2 and then like this. Histidine, I just drew somewhere few seconds back. Where we drew, here is histidine. Okay, phenylalanine, yes, phenylalanine is also having aromatic group. So amino acids which have aromatic group in them are tyrosine, tryptophan, histidine, and phenylalanine. But if we are asked how many of them have benzene, then it is tyrosine, tryptophan, and phenylalanine, not 2, only 3. Okay, 3 have benzene ring present in them. Yes, but tryptophan, this is not exactly benzene. This is different heterocyclic compound also. So if they are just strictly benzene, then answer is only tyrosine and phenylalanine. Is that clear? All amino acids are chiral except glycine. Histidine is the most basic. Aspartic acid is the most acidic amino acids of all. Is that clear? No problem with this. I'm stopping at this page for few seconds so that you can revise it all. And rather, I should refine this statement here. I will consider only benzene, then take only this 2. Okay. I will say, I will change something. Rather, I will add here. Tryptophan may, I will change. Tryptophan has indole structure in it. तो उसको मैं purely benzene वाला नहीं कह सकती. I can't call it absolutely कि it is a benzene structure. Is that clear now? Why I didn't want it to be there in that list. Is that perfectly fine to all of you? Right? So I'm adding this line here, and now it will be there, has indole structure in it. Yes, it is aromatic, but it does not have simply benzene नहीं बोल सकते, वो indole है. So moving to next point, what are the properties of amino acids? So of course they have very strong hydrogen bonding setting. So they are crystalline solids at room temperature. They are colorless. They are water soluble because of polar poles, polar ends in the molecule. And as they have those zitter ions, so yes, they have high melting point than expected. All these properties indicate presence of zwitter ion. It is a dipolar ion, though overall it is neutral, but it is a dipolar ion. So what is a zwitter ion? So due to intramolecular acid base, see this is the alpha amino acid now. This is the acidic part, this is the NH2 basic part. So they exchange H plus intramolecularly and have this polar species. Overall, it is neutral, but it has the dipoles. One end is negative, one is positive. This is called zwitter ion. And here we are starting a very, very important question zone. Dipolar ion, zwitter ion, minus and positive. So this is the Ka that we expected, that carboxylic acid. This was the Kb we expected. But what we found is in fact absolutely different. We did not find the Ka of carboxylic acid. We observed the K of the conjugate acid of NH2. Are you getting my point? So entirely different thing. I was expecting K of carboxylic. I am getting K of conjugate acid of NH2. I was expecting Kb from NH2. I am getting Kb of conjugate base of COH. So which is very, very different. And therefore, we got a hint that the things are not what we are seeing, that okay, just COH-NH2 nahi, something else is there. And there we comes to something called zwitter ion and then isoelectric pH. Now what happens that the different forms of amino acid like the neutral and the ionic will be in equilibrium. Yes, but further they will be in different forms based on the pH of the medium. The pH at which the concentration of the dipolar ion is maximum is called the isoelectric pH of that amino acid. And of course, it will be different for different amino acid because they are different K1, K2 will be there. Now, learn how to find the isoelectric pH of amino acid. This is a very important question zone. So, start with protonation of all possible end in the molecule. Learn the sequence. I will protonate all possible. So, it was alpha. First, I am starting with neutral amino acid. So, this alpha NH2, I am making NH3 plus. Okay, alpha NH2, I'm making NH3 plus. So alpha NH2 is made with made NH3 plus conjugate acid, full cation possible. Now I start, okay, I add OH minus, which will go, so I'll say COH will go first, more acidic is COH. And that K1 is of COH. Then I further add more base. Now NH3 plus will go and anion is forming. If in this anion, I start decreasing the pH, I start adding H plus, this is a stronger base center NH2. So it takes the H plus first. Then this takes, so cation. Now, to give the value of isoelectric pH, you have to find that zwitter ion is placed between which two species is a part of which two equilibriums. Like here, my zwitter ion is placed between K1 and K2. So once you get where it is, zwitter ion is in between, sandwiched between which two Kas, just average out of those two pKa values is the isoelectric pH. So direct. Yes, derivation is there in the physical, all good. But how to approach for organic? Directly do pK1 plus pK2 by 2. That is the isoelectric pH of this amino acid. And a very good thing that for all neutral amino acids, the isoelectric pH is found to be somewhere around 5.5 to 6.5. Slightly acidic zone, you can say 5.5 to 6.5. So at this pH zone, they will exist as zwitter ion. If I say that what will be the existence of this neutral amino acid at pH, say 9, 10. 9 and 10 matlab it is greater than isoelectric pH. Greater than isoelectric pH, it will exist as anion. If they say what will be the existence or species existing for this neutral amino acid at pH 2. So pH 2 is less than this. It means it is more acidic. So I have to make more acidic. Then what is this existing species? This species you will report it exists as a cation. Okay, neutral amino acid. So an amino acid above its isoelectric pH will exist as anion. Below its isoelectric pH will exist as cation. Okay. If it is an acidic amino acid. So here I am taking example of aspartic acid, which is CH2COH. Okay. Aspartic acid, which is a CH2COH. So now you have two COH in your molecule. One is this, one is this. You have one NH2 here, right? As I said, start your writing from all sets wherever H plus you can give them all the H plus. So COH I will make neutral and NH2 I have made NH3 plus. Now gradually you start adding base. So I add OH minus. First you will check which will be the strongest because stronger acid will be the first to deprotonate. So this is I found. This is the strongest acid. I removed H plus. And one H plus you remove at a time. So I have Ka1. Then I have NH3 plus and COH. Of course, NH3 plus versus COH. COH will be the stronger acid center. Oxygen attached H will be more acidic than nitrogen. So COH I took. Okay. Now I got 2 minus 1 plus. So is it a zwitterion? No. Because zwitterion should have a neutral character overall. 1 plus 1 minus is cancelled. So overall it is neutral and it is polar. This is a zwitterion. This is no. Plus minus cancel. 1 negative is extra. So I will rather call it as anion. I add more OH minus. Then this NH3 plus can go. So I'll have a dianion. Okay. Now see, now zwitterion is sandwiched between K1 and K2. So I will say isoelectric pH is pK1 plus pK2 by 2. You got it how to do? And for acidic amino acids, again, there are two acidic amino acids. One is aspartic, one is glutamic, and it is found 3 and 3.2. So you can roughly say it is 3. Just to remember, right? For acidic amino acid, isoelectric pH is towards acidic zone 3. For neutral amino acid, it was 5.5 to 6.5 zone. Let us see what for basic amino acid. So for basic amino acid, I should have more number of NH2 over COH. See, 1 COH, 2 NH2 groups. Okay, so as I said, start with the full protonated structure. Whatever, wherever there is possibility, give. So as 2 NH3 plus, because it is basic amino acid, lysine I am taking. Okay, this time my example is, I am taking example of lysine. Is that clear? So CH2 4 times NH3 plus. Okay, fine. Now first K1, if I introduce OH minus, of course, acid will go first. Gone. Next, remember the alpha NH3 plus is the more acidic center than this distant one. So this is gone. Okay, this is gone. Now, is this a zwitterion? No. Plus, minus 0. Yes, this is a zwitterion. Is this a zwitterion? No. This is 2 plus single minus. So it is a cation. Dication, cation, zwitter. Now I add more OH minus. Then I will have this NH3 plus also lost. So this is an anion. So zwitterion is sandwiched between K2 and K3. So isoelectric pH is pK2 plus pK3 by 2. Clear? Whichever two K's के center में zwitterion is placed, average of those will give you the isoelectric pH. So basic amino acids have isoelectric pH of from 7.6 to 10.8. So that is greater than 7. And out of these, this 10.8 will be of which one? Histidine, the one which has the, arginine, the one which is the most basic amino acid. Amino acids show minimum water solubility at isoelectric pH because they are overall neutral. So they have minimum water solubility at isoelectric pH. Below isoelectric pH, they will exist as a cation. Above isoelectric pH, they will exist as anion. ठीक? Reactions given by amino acids. With HNO2, they gives alcohol. Okay. And I think you already know this. NNO2 plus HCl, NH2 will be replaced with OH. That is okay. That you know. Very good. But that is with retention of configuration that you need to remember. And why is it so? So, let me explain how this takes place. So, when I say RCH, if I take, just let me write it more detailed version, COOH, and I will write this. I have to check whether I'm drawing, if I place here NH2 here on wedge. So, have I drawn NT arrangement? Yes. If I will draw it as Fisher, is it an L amino acid? Yes. Just check, this is an L amino acid. How to check? You may ask how to check. Simple method. In L amino acid, we said NH2 should be on left, H here, and R here. So arrow कैसे जा रहा है? Clockwise, but H is on horizontal, so you put it as S. Now check here, is this S? Yes, this is S. So I have drawn L amino acid. I have drawn it correctly. Now this L amino acid, you will check कि reaction कैसे हो रही है, how this reaction is taking place. So NNO2 plus HCl, NO plus attack. So RC N2 plus diazonium is formed, H, okay, COOH. Now, as I said, there is NGP. This attacks, N2 is released. So CR, okay, H, this will be now wedge, and this is now oxygen, carbon, okay, double bond O, H positive. When again water OH2 comes, it attacks, goes back. So again things fall in place and OH अपनी जगह ले लेता, H अपनी जगह, and COH gone. So retention of configuration. This is what we are saying. Okay, there is NGP. What we just observed is neighboring group participation of COH. So that is a very important question. Alpha amino portion is substituted to OH, but with retention of configuration. With acetyl chloride, it forms amide. Yes, here no configuration change. This is a simple reaction of NH2. It forms salt with strong inorganic acid because NH2 will act as a, rather CO minus will act as a basic center. Right? Because Zwitterian existence is more. Then due to COH. COH first acid plus alcohol forming ester. That reaction will be observed. If I reduce it with LH, COH will be reduced to CH2H. Okay, no problem. That also we know. It liberates CO2 with NHCO3. Nothing new. All carboxylic acid reactions. Reactions due to both NH2, so Zwitterian formation, high water solubility, and high melting point. These are the properties which are explained by Zwitterian formation, and Zwitterian is explained by the presence of both NH2 and COOH group. Okay, Structure of protein. Now we have once studied what are amino acid. We have tried to learn them. Now it is studied at 4 levels: primary, secondary, tertiary, and quaternary. Primary structure, the exact sequence and number of amino acids present in a protein, that is called the primary structure of that particular protein. Amino acids bond together by amide linkage to form polymers. This amide linkage is called, what is it called? It is called peptide linkage. And the polymer जो बनेगा उसे कहेंगे dipeptide if there are 2 amino acids. Tripeptide if 3 amino acids. Polypeptide if 10 or more. Polypeptide having 100 or more amino acids joined and having mass greater than 10,000 units, then it is called proteins. Though this is not a rule, smaller polypeptides are also called proteins if they show the properties of protein. Example, insulin has only 51 amino acids. And it says more than 100 amino acids here, na? But insulin is called protein, right? Whenever the 2 amino acids combine, see the acidic part and the amine part, they are reacting and removing water. So we got this amide linkage. Okay, this amide linkage we call this peptide. Now, whenever you write the peptide linkage, there are 2 possibilities. Now, you can write this as a left-hand side. Like you can use acid of this one, R-1, and amine of R1, or you can use R ka acid, R-ka NH2. So those 2 will be treated as a different amino acid. They are not identical. Okay, that is a rule. And when you write a peptide chain on paper or any polypeptide linkage, then always remember the amino acid whose N-terminal or NH2 group is free is called N-terminal amino acid. And the amino acid whose COH group is free is called C-terminal. And while you write on paper, N-terminal has to be on the left-hand side. Okay, on paper, polypeptide or protein is written from N-terminal end to C-terminal end. So you start with the N-terminal and you end with C-terminal. That is a rule. Number of amino acid present in a peptide chain -1 is the number of peptide linkage. If I have 2 amino acids, they will be bonded by 1 peptide linkage. So number of amino acid are 2, peptide linkage is 1. 3 amino acid, then I will have 2 peptide linkage, now 1 and 2. 4 amino acid, then 1, 2, 3. So the number of peptide linkage is always number of amino acid minus 1. That is fixed. And 1 peptide linkage loses 1 water when it is formed. If I want to go back to hydrolysis and get amino acid, then 1 peptide linkage will need 1 water molecule. Clear? Secondary structure of protein. It is defined by the local conformation of a polypeptide. Once we saw that this way it can form big molecules. Just wait, I want to check. Okay, let me add one more point here. So this, whatever we have said, if we have n amino acids, then number of they may ask number of dipeptide formed from them is. Okay, so it is usually n to the power 2. Let us check. If I have 2 amino acids, A and B, so this value is 2 raised by 2. So I will write 4 dipeptide. Na? So I should have 4 dipeptide. So AA, BB, AB and BA. So I have 4 dipeptide. If I am given 2 amino acid. And now I am asked how many tripeptide. Tripeptide are to be formed. So I'll say n raised to power 3. Okay. So 2 raised to power 3. I should get 8. Let us check. Tripeptide. A, B, 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 A, B, B, A, okay, A, B, A. These are different. These are different amino acids. Sorry, different, what should I say, tripeptide. BAA and AAB are different. Coming to 2B cases. So I will have B, B, A, right? Then A, B, 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 A, B. So I have 8 tripeptides. That is what I was saying. If I have 3 amino acids, okay, and asked how many, say, tripeptides are formed. Tripeptides are formed. So what you will do, you will simply say there are 3 amino acids and tripeptide. 3 raised to power 3 is your answer, 27. Clear? And analysis of primary structure of protein. Structure of protein is done using Sanger method. Sanger method. Sanger reagent, you have to remember. Sanger reagent is 2,4-dinitrofluorobenzene. 2,4-dinitrofluorobenzene. See, it is good for SNAR. Principle used is SNAR. Attack starts from N-terminal amino acid. It always attacks N-terminal amino acid. That is fixed. So there is a fixed sequence of amino acids which is there, then only it becomes a particular protein. If the sequence is not maintained that way, then it cannot become the amino acid. Okay, that amino acid particularly can be when the fixed sequence is maintained, otherwise it can cause diseases. So secondary structure of protein. Now let us see. By local configuration, we have 2 structures or 2 points in this. One is the alpha helical, one is a beta pleated. Beta pleated is like the way we put curtains, or the pleats are formed, pleats of a sari or a dupatta, that way. So it is defined by local conformation of polypeptide chain, right? First is a alpha helices. So it is a right hand thumb rule. Simple. These structure arise due to the regular folding of the backbone of the polypeptide chain. But what is responsible for secondary structure? Hydrogen bonding between them, carbonyl and NH, groups of the peptide. These are the backbone of the structure. That is how they keep them intact. Otherwise, the structure would be like a spring. This beta, this is a zigzag pleat, and the one layer is hydrogen bonded to another, and then third, then it is a layered structure which is generated or created. Tertiary structure is not in the syllabus, but the types are in the syllabus, so we have to do little. The tertiary structure of protein represents overall folding of a polypeptide chain. It gives rise to two major molecular shape. One is fibrous, which is a thread-like, fiber-like, when the polypeptide chains run parallel and are held together by hydrogen and disulfide bonds, then the fiber-like structure is formed, and these are insoluble in water. Example, keratin, which is present in our skin, hair, wool, nails, etc. Myosin, which is present in muscles. Globular, they are like coiled ho jate, they get dry hay jo hota hai na, how it becomes coiled, that type globular protein. They are formed when the polypeptide chain coil around to give a spherical shape. These are usually water soluble, example insulin and albumin. The main forces which stabilizes secondary and tertiary, see this is objective, 4 points directly. The main forces which stabilizes secondary and tertiary structure are hydrogen bonds, disulfide linkage, van der Waals forces, and electrostatic forces of attraction. Please remember these four. Okay. Quaternary. Some of the proteins are composed of two or more polypeptide chain. Then they are referred to as subunits. The spatial arrangement of these subunits, okay, with respect to each other is known as quaternary structure. Denaturation of protein, irreversible loss of three-dimensional structure of protein at high temperature or extreme pH is called denaturation of protein. And in denaturation, we never lose the primary structure. We simply lose the secondary and the tertiary structure. But the primary structure, that is the sequence of amino acid, remain same. Okay. Last point of this chapter or protein is test. First is the ninhydrin test. Ninhydrin, you know. So when we add protein to this, it is given by practically ammonia, primary amines, amino acid, peptides, all give ninhydrin test. So here, the middle one, you get double bond N, and then again another molecule of ninhydrin is there. So this is a purple color complex form, purple color compound form. Ninhydrin is a powerful oxidizing agent and reacts with protein to give a blue-violet compound called Rumann's purple. It is a solution, not a precipitate. Okay. Next is the biuret test. Now, biuret, if you see, is somewhat like urea, NH2CONH, and again CONH2, and so on. Somewhat like urea. So, alkaline copper sulfate is our biuret reagent, test reagent. It is given by any two compounds which have two or more peptide linkages. So, here these are the peptide linkages, na? Right? And what they form is this type of complex with copper. See, this complex is a violet color. So appearance of that violet color confirms the biuret test. Xanthoprotic test is given only by aromatic groups, not by all. Of either the free amino acid or a protein undergo nitration on heating with concentrated nitric acid, and the salt of these derivatives are orange in color. See, first we get nitration. So you get nitro on the ring. That is a yellow solution. When we add NaOH, then some salt is formed which is orange color. So by that we confirm xanthoprotic test. Okay. Wait, Sanjay. Let me complete, then you can ask. And then here I have added some PYQs. If you want to do it, you can do it. Right? See how the questions were asked. In alanine, glycine, leucine, alanine, valine, the number of peptide linkages. So there are 1, 2, 3, 4, 5 amino acids. So you will say 4 peptide linkages are there. How many of the given compounds will give positive biuret test? Glycine, no, because as I said, it should have at least 2 peptide linkage. Glycine and alanine will have only 1 peptide linkage. So ye bhi nahi dega. It is tripeptide and biuret which will give biuret test. The structure of protein that is unaffected by heating is the primary structure. Is that clear? See? So that is how the questions have been framed. And now let me go to this point where, so that completes my routine. Is there anyone who wanted to ask? I think Sanjay was raising hand. So please ask. Whoever wants to ask a doubt from proteins, please ask. Then I'll go to nucleic acid. Yes, Sanjay.
Ma'am, the previous test which you showed, ma'am, second test, can you please go to that, ma'am?
This one.
Ah, yes, ma'am. Ma'am, what is the hybridization for the copper in this one, ma'am?
Well, I didn't check, but it seems to be, दूर से देखने पर it seems to be either sp3. It appears to be sp3, but you can check.
No, ma'am. What confuses me is the bridging ligand, ma'am.
That doesn't have any influence on individual copper, I assume.
Okay, ma'am.
Ekansh,
Ma'am, in the questions which you were showing right now, the second question.
wait. Let me go there. Here, Ekansh.
Yes, ma'am. The 14th one.
Yes, this one.
Yes, ma'am. I didn't get
Okay.
that.
It is asking number of peptide linkages. I told you peptide linkages, number of peptides minus 1.
Hmm.
So whatever they are giving, see, I'm marking alanine, glycine, lucille, alanine again, valine. So how many amino acid? 1, 2, 3, 4, 5. Okay. 5
Ma'am, but
amino.
isn't alanine repeated?
Still, when it is there, does not matter that those amino acids have to be different to form to name it as a pentapeptide or whatever the structure is. 5 amino acids, so pentapeptide. So it doesn't have any impact. Like say A is alanine, G is glycine. So there is one peptide linkage, na? Then lucille, then again alanine, then again valine. So 5 amino acids. And how many peptide? These horizontal lines are the linkages. So I will have 4 linkages. It doesn't have an impact. The peptide linkage तो होगा ही ना, जब वो जुड़ा है तो वहां पे लिंकेज तो बनेगा ही.
Yes, sir. Got it.
ठीक. अच्छा सुन, अब एक बात और यहाँ पर, अब जैसे कभी एक कॉम्प्लेक्स बोल दे, इसका सवाल का एक और कॉम्प्लेक्स वर्जन, ऑल ऑफ यू लिसन दैट दे हैव गिवन दिस. नाउ दे से देयर इज, दिस इज नॉट देयर, है ना, आई एम रिवर्सिंग द क्वेश्चन. They say that we did hydrolysis of a this what you call polypeptide or a protein or whatever they call, है ना, and it has, they say कि 1 2 3 4 5 pentapeptide है ना, it has 5 amino acids. 5 amino acid need not to be same. We are said कि you are allowed to use 2 alanine, 1 glycine, 1 leucine and 1 valine. Okay, you are allowed to use this. Now you have to identify the sequence. So they say we get following pieces on hydrolysis. So random, say anything. So say one piece was GLA, one piece was AGL, one piece was LAV. Okay. Now if they will repeat again, it would have been just same. But let me say these type of pieces they are reporting. And now they are asking you that what is the structure. So how you will arrange? You have to be like a puzzle form. So AGL. So anyhow, GL seems to be okay. I'll put GL because GL दो में repeat हो गए. LA, LA. So I say कि okay, then it is followed by A. Clear? Once A is preceded and one this AG, AGL, AV. That also you should be spontaneous how to decide. Is this thing clear? Okay. Okay. So Mihir, ask.
Isn't guanidine more basic than imidazole?
Yes.
Why is
That is why we said na. Huh?
histidine more basic than arginine then?
Let me check what is we are talking. We said arginine only, na? But at isoelectric pH 10.8, 7.6 sahi to hai.
I thought you mentioned histidine is the most basic amino acid.
I might have by error, but definitely it is the guanidine thing
It
only.
was written in the notes, like
No, it was not.
I think
It
so.
was not written in the notes. I might have just mentioned verbally. See this. So here I would have said arginine only.
I remember seeing a point.
No, I might have verbally made an error, but not written. Just
Ma'am,
identify
but ma'am, previous slide, bottom point.
this.
No,
This.
next slide,
This.
bottom point, bottommost.
Yes, here. No. Here I should put arginine. Thank you. Certainly arginine. Arginine is the most one. 10.8 उसी का ही है.
Okay.
Thank you, Meher, for correcting us. Arginine.
Yes, ma'am. Number of amino acids with sulfur, if they ask in exam, should we mark 2 or 3?
No. If they ask naturally available, mark 2.
Okay.
Because NCERT has only 2. That is why. This is Solomon cutting.
So
Okay.
cysteine is not considered.
What is not considered? Dimer is not
Dimer
considered.
is not.
Cysteine.
Okay.
Cysteine is not considered. Cysteine and methionine are only 2 which are given in NCERT.
Yes, ma'am.
Okay, so take only those 2.
Thank you.
Shrey?
Ma'am, in the previous year questions, how do they mention the names of the amino acids?
Who?
Do they call it as, do they just write glycine or do they write GLY or do they just write?
Oh, that is either. They can write this way, they can write single like this. Single, yeah, these representations will be used.
So
C, CY. But usually they will give some hint in advance. In mains, I don't know. In mains, they can use YWST type thing. But in advance, they usually give that glycine bracket G, alanine bracket A type thing.
Okay.
Okay. But in mains, I cannot guarantee. वो तो तुम भी जानते हो कुछ भी हो जाता है ना. There I can't say. Okay. Sanjay?
Ma'am, the book which you're referring to for these data is...
These the one which is on screen?
Yes, and for the previous chapters also, ma'am.
Oh, please, I keep on changing the books, whichever is best for that data. Here I'm using this is Solomon.
Solomon, and we have 2 books, ma'am.
No, I keep on changing, but I there is no fixed book.
Okay, ma'am. For this one, Solomon and Boyd, ma'am.
No, not Boyd. Boyd is Morrison and Boyd. This is just Graham Solomon.
Okay.
G. Solomon. So this amino acid, I found that zwitterion explanation, the graphs and everything in Solomon is very colorful and nice. So I used Solomon. For other things, usually the data of Ka, Kb tables, I use Vade. For mechanistic things, I use either Claydon or use Sunderberg. And then some concise things, you may use Peter Sykes. So, but that is not what I will suggest you to go to book. That is our work as faculties to compile the best and give to you. So you don't invest energy for searching the books. You go by the notes. Okay, that is our department. Okay. Anything else with the what I said, this protein thing? Nothing. So let us try to. We still have around, I think, 10 minutes, 20 minutes, something. Oh, it is 8:11. So what should I do? Should I postpone nucleic acid to tomorrow then? Or else I should try to finish today. So let us start. At least 10 minutes we can do, and so that tomorrow I will take minimum of your class and you can invest your energy on revision. Okay? Because lot of subjective part, revision part this week.